Okay, so in the last video I showed you how to create this the simple rising edge example. Now I'm going to show you how to debug it. So I've got, in this case, this happens to be an ACE 11, and I've got that plugged in to my system. I'm going to go ahead and program it, and I'll tell it to run, and then I'm going to kick it off in a debug mode. And you see when we toggle the names on off, I can see the values inside. Okay, so you see right now the input bit is off, and I've got a simulator stick plugged in, so I'm gonna toggle that in a second. So right now, if we were to set a breakpoint here, we could step through its operation. We see exactly where it's going. It's just following the path we'd expect. I'll let it run. Now I'm going to go ahead and flip my switch. Okay, so for a brief moment there, and it was so brief we couldn't even see it, it passed this full example, and I'm going to go ahead and I'm going to turn it off. I'm going to set a breakpoint here so that next time I switch it, which will be right now, it'll actually cause this to happen. So for this brief moment, it passed, and we're going to see where it goes from here. I'll single step. Now all of a sudden state is equal to 1, so it goes through, it starts a timer, and it's going to move to state equals 2. So it's going to go here and then back around, and the next time it'll go to state equals 2. Yep. So I still have the switch on, so it did that. State equals 2 is true this time, and it'll just keep hanging out in that loop until 3 seconds elapse, which the timer doesn't keep going while you're single stepping like this. It would take far too long to do that anyways. So I'm going to clear my breakpoint. I'm going to tell it to run. But what we're going to notice here is the output bit. Okay. Yes, right here. You can see the value of the output bit. You see that's output bit D1. It's a 1 right now. You'll see that it'll stay on for basically 3 seconds. You'll see it right here, and then it'll change to 0. So 1, 2, 3, 0. There it is. Okay, so it hung out in this set 3 seconds, and then it cleared that value of the bit equals 1. I could see it on my little test setup here. I can see the output D1 on for 3 seconds, and then it flips off. So that's that. You may have seen that the last second there when I turned it off, it actually caused the sequence to happen, and that's a result of something called mechanical debounce. You may experience that at times when mechanical switches go from when you're toggling from an on to an off, or you're pushing a button of that nature, and it's a real mechanical system. Sometimes they'll bounce back and forth just a little bit in tiny space of time, and our processors are very very fast, so they can catch some of those. And there are ways, if you don't want to see very high speed transitions, that you can filter those out. But without filtering them, you can experience them, and that there are times you want to catch high speed things, so you're able to do that.